How long do plants store carbon? Well, a new study finds that plants store carbon for shorter periods than previously thought. Well, this is a bit concerning. The carbon stored globally by plants is shorter lived and more vulnerable to climate change than previously thought, according to a new study. The findings have implications for our understanding of the role of nature in mitigating climate change, including the potential for nature-based carbon removal projects such as mass tree planting. The research carried out by an international team led by Dr. Heather Graven at Imperial College London, published in Science, reveals that existing climate models underestimate, here we go again, everything underestimates the amount of CO2 that is taken up by vegetation globally each year, while overestimating how long that carbon remains there. So basically, the models underestimated how much CO2 plants uptake, so that means plants uptook more CO2 previously thought, but they thought the carbon remained for a lot longer period than it actually does. So, as she said, Dr. Graven, plants across the world are actually more productive than we thought they were, but the finding also means that while carbon is taken up by plants quicker than thought, it's locked up for a shorter time, meaning carbon from human activities will be released back into the atmosphere sooner than previously predicted. So what's the net? What's the overall net? Is the overall net that CO2 or that carbon accumulates more in the atmosphere? Or is it that it's still being drawn down but at lesser amounts? Now, when I talk about the carbon accumulating more or not as much, I'm referring to the release of what had been sequestered. I am not including in that statement the continual burning of fossil fuels that adds carbon to the atmosphere. I want to make that clear. So this is, again, where you got to get into budgetary studies. What's the input? What's the output? Okay, the plants uptake more CO2 than previously thought. Okay, that's good. But then the carbon's not sequestered for as long. It's released sooner than thought. That's not good. And then how much of that is released? All of it, some of it, what's the fraction? And then again, when comparing to into the plants and out of the plants, what's the net? Is it less CO2 in the atmosphere or more CO2 in the atmosphere? Many of the strategies being developed by governments and corporations to address climate change rely on plants and forests to draw down the CO2 and lock it away in the ecosystem. Our studies suggest that carbon stored in living plants does not stay there as long as we thought. It emphasizes that the potential for such nature-based carbon removal projects is limited, and fossil fuel emissions need to be ramped down quickly to minimize the impact of climate change. Well, we're not going to mention anything about ocean heat content and the heat diffusing and all that kind of stuff, right? Thermal inertia, pipeline warming, yada yada, right? Until now, the rate at which plants use CO2 to produce new tissues and other parts globally, a measure known as net primary productivity, has been approximated by scaling up data from individual sites. But the sparsity of sites with comprehensive measurement means it has not been possible to accurately calculate NPP globally. Plants' productivity has been increasing since the early 1900s, and more CO2 is currently taken up by plants than is released back to the air. Researchers know that approximately 30% of CO2 emissions by human activities are therefore stored in plants and soils each year, reducing climate change and its impact. And how much is in the oceans? As the oceans warm, that CO2 outgasses. However, the details of how the storage happens and its stability into the future are not yet well understood. Now, I'm wondering about this statement here, plants' productivity been increasing since the early 1900s. What's the reason for that? Is it better farming techniques? Is more of this from an aggressive agricultural procedure and methodologies? That's not clear to me. So yes, if you have plant productivity increasing, it's going to draw down more CO2, but how does that drawdown compare to the CO2 that's pumped into the system? The fact that we still continue to measure an increase in ppm of CO2 would indicate that the addition of CO2 into the atmosphere is greater than what our plants in toto are drawing down. So we have, and this is not easy work, folks. Doing carbon budgets as comprehensive as possible, it is very difficult work, but this is what's needed to be done. What you need to do is you need to get, each scientist studying their specific thing, need to just take all this info, all these studies, and dump them together. Put it into a big supercomputer. Crank it, see what happens. In this study, carbon-14, which is a radioactive isotope, was combined with model simulations to understand how plants use CO2 at a global scale, and they got some insights. Radiocarbon is produced naturally, but nuclear bomb testing in the 50s and 60s increased the level of C14 in the atmosphere. This extra C14 was available to plants globally, giving researchers a good tool to measure how fast they could take it up. By examining the accumulation of C14 in plants between 63 and 67, a period when there was no significant nuclear detonations, good, and the total C14 in the Earth's system was relatively constant, the authors could assess how quickly this carbon moves from the atmosphere to the vegetation and what happens to it once it's there. The results show that current, widely used models that simulate how land and vegetation interact with the atmosphere underestimate NPP of plants globally. The results also show the models overestimate the storage time of carbon in plants. So, co-author Dr. Charles Coven from Lawrence Berkeley National Lab in the U.S., these observations are from a unique moment in history just after the peak of atomic weapons testing in the atmosphere in the 60s. The observations show that the growth of plants at the time was faster than current climate models estimate that it was. The significance is that it implies that carbon cycles more rapidly between the atmosphere and the biosphere than we have thought, and that we need to better understand and account for this more rapid cycling in climate models. So they say that more research is needed to improve the models, the hypotheses about how plants grow and interact with their ecosystems, and to make the appropriate adjustments. Co-author Dr. Will Weider from the NCAR, Boulder, Colorado, said, scientists and policymakers need improved estimates of historical land carbon uptake to inform projections of this critical ecosystem service in future decades. Our study provides critical insights into terrestrial carbon cycle dynamics, which can inform models that are used for climate change projections. The work highlights the usefulness of radiocarbon measurements in helping to unpick the complexities of the biosphere. The research also included German physicist Ingeborg 2011, a pioneer in radiocarbon and atmospheric research who unfortunately passed away in February. So, to sum up, plants take up carbon quicker. Okay, so the NPP is quicker. But the carbon does not stay sequestered for as long as thought, being released to the atmosphere sooner. That's basically what they're telling us. So now what has to be determined is, will this ultimately lead to an accumulation of CO2 in the atmosphere, or will the drawdown continue? Again, considering just the role of the plants. We know that the CO2 and the CO2 equivalents continues to increase. So the fact that it's continuing to increase basically informs us that that is greater than any removal plants are doing. And don't forget the role of oceans and phytoplankton and warming oceans and the gas solubility decreasing, resulting in outgassing of CO2. Very complicated system. Very complicated couple system. But you need to make and construct the budgets. So, interesting finding. Thought I'd share that with you. We'll talk soon.